let's consider the function, the equation dp dt equals kp plus m. Now this is of the form p prime plus p of t times p equals m, where this is little p of t, and I've written it really little. We have to distinguish this p from this p. We could also write this in the form y prime plus p of t y equals m, to be sure that we can relate to what's going on. This is first order linear equation. It's non-homogeneous. We've got m over here. Now this equation would correspond to an interest rate k and a money flow m. That is, we're putting money in at the rate of, say, m dollars per year. So the dp dt is automatically growing by m dollars per year, but also we're getting interest on p, whatever p happens to be. Now what do we do to solve this equation? We multiply both sides by e to the integral of p of t dt. Now what's our p of t function here? Well, it's the coefficient of p. So it's, if we put this into the form, this is p prime minus kp equals m, so that our little p of t function is negative k. So we multiply by e to the integral of k, negative k, dt equals e to the negative kt. Multiplying both sides by e to the negative kt, we get e to the negative kt times p prime minus k e to the negative kt times p equals m e to the negative kt. This side, and we can do the derivatives and verify this, but I'm not going to go through that step this time. This side of the equation gives us e to the negative kt times p prime. Take the derivative of this, we get this, and that equals m e to the negative kt. Continuing the solution, if we integrate both sides, and I'll write out the integral just to reinforce the idea, e to the negative kt times p prime with respect to t equals the integral of m e to the negative kt with respect to t. And we can see that we've lucked out. We've got an easy integral on this side, and of course this integral is even easier because we're taking the integral of a derivative. The integral of our derivative is e to the negative ktp, and the integral over here, which you can check out, is just negative m over k e to the negative kt, and it's a bad looking e. It's difficult to fix with this marker. And we can add an integration constant over here, something we didn't do in previous examples. So now, what's our solution? Well, we just solve for p, and we're going to divide through by e to the negative kt. I don't want to write out all the algebra here for sake of time and so forth, but it's going to be negative m over k plus c e to the kt. And this should be our function, but I think there's something wrong here. We'll try to check on that in a minute.